Number 9, Michael went to a driving range with his rangefinder, hit 75 golf balls with his pitching wedge and measured the distance each ball traveled. The accompanying table shows his data. We're going to complete parts A and B. So we want to draw a normal density function on the relative frequency histogram. So we're going to comment on the shape. So we got several different graphs. So we're going to use this data. We are going to copy it in Excel. We're going to let this draw the histogram for us. Now, this graph is looking at the relative frequency. So the distance the ball traveled and how many times it was hit that distance. So we're not even really using the drive, like when it happened. We just want to know the distance. So some of these are repeated. So we're just going to use this column right here. Drag and copy 75. We're going to go to Insert. We're going to use the histogram. We're going to do, no, not that, just the histogram. Now, if we look at each of these graphs, I want to try to get the spacing about the same. One thing we're going to be asked is how many sections do we want. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9. This one has 9. 5, 6, 7, 8. That one has 9. 9. Okay, so they all got 9. So in the spacing, 1, 2, 3. So they just counted by ones. They start at 93 and go up to about 105. So I'm gonna click this chart. I'm gonna go to Axes. I'm gonna go to More Options. Bins. So bin width, we're gonna call it 1. Looks like we're counting by ones. And the number of bins, we're gonna make it 9. It might adjust it a little bit, but it should be pretty close. Okay, so here is what my data looks like. I got a up, down, and then we go up, and then we go down. So I'm looking for the graph that looks most like that. This one looks pretty good right here. Is there any other one that looks that close? This one looks pretty close. What's the difference in these two? This one is going out to 104, almost 105. This one stops. So I just need to look at, I guess the frequency of this last one looks to be a little bit different as well. But if we compare the y-axis, okay, so the relative frequencies are going to be a percentage, the percentage of times. The difference in these two is the y scale. The graphs look almost identical when I looked at them a little bit more. Pretty close, but the frequency, relative frequency, is going to be a percentage. How many times did we hit it that out of 100? And this one does not have the right labeling, so D is going to be the best option. We're going to comment on the shape of the distribution. If we look at this, I mean, we can say it's roughly normal. It's kind of hard to say skewed left or right, really either way. So I'm going to say it looks roughly normal. Not exactly, but just roughly. We would draw a curve over our graph. So basically you look at the labeling. Again, this one looks flipped. The line is not drawn correctly there. So this one is the one that's like roughly normal, same shape, right frequency. As you look at the labeling, I would throw A and B out just based on the labeling. So I would have these two to choose from, and D would definitely be the better one. And then last part B, do you think the normal density function accurately describes the distance Michael hit his pitching wedge? Why? So do you think the normal density function accurately describes? So if I look at the previous up here, you see some of them, this curve does not actually go, but it's close, it's rough. So we'll say yes, the histogram shape resembles a normal curve, and the area of each bar is roughly equal to the area under the curve for the same region. Yes, the distance he hit the ball is a random variable, so it's normally distributed. Nope. No, sometimes higher, sometimes lower. That is the case. Sometimes they're higher, sometimes they're lower. But one of the things we hadn't talked about yet is that when you go up above 30, that's in the past textbooks, when you do an experiment 30 times or more, generally, we're going to say that the pattern is going to be roughly normal. That's kind of like a threshold to be able to use the normal distribution. So since this is above 30 attempts or 30 repetitions, this can be roughly normal. Now, of course, it is some are higher, some are lower, but that's going to be the case when we're just estimating. So, yes, it resembles the normal curve. The area of each bar is roughly equal to the area of the normal curve. Roughly, very rough. Some of them are lower, some of them are higher, but we don't need to be exact. It's just close.